Today we are going to discuss the topic pattern matching from the Unit 3 Efficiency in Business Intelligence. Let's understand what is pattern. Pattern is everything around in this digital world. A pattern can either be seen physically or it can be observed mathematically by applying the algorithms. For example, the colors on the cloths, the speech pattern, etc. In computer science, a pattern is represented using vector feature values. Pattern recognition is the process of recognizing patterns by using a machine learning algorithm. Pattern recognition can be defined as the classification of data based on knowledge already gained or on statistical information extracted from patterns on or their representation. One of the important aspects of pattern recognition is its application potentials. Example, speech recognition, speaker identification, multimedia document recognition, automatic medical diagnosis. So pattern matching is another terminology which is a computational technique used for searching and identifying specific patterns or structures within data such as text, images or other types of data. Pattern matching is a technique used in programming that involves checking a given sequence of tokens for the presence of the constituents of some pattern. Essentially, it's a way to identify and process data that fits a particular structure or sequence. The pattern matching process involves comparing input data against the defined pattern. If the input fits the pattern, it's considered a successful match and certain actions may be triggered. Pattern matching produces definite results. The input string either contains the pattern which is valid or it doesn't, it is invalid. So the various applications of pattern matchings are natural language processing, which is a spelling and grammar checks, and it is used for sentimental analysis. Computer vision, which is used for identifying the tumors in blood, and bioinformatics, which is helping into identify the sequence alignment, gene prediction, and metagenomics. And predictive maintenance, in which the sensor data analysis, failure prediction, root cause analysis are utilized. And in fraud detection, the anomaly can be detected or behavior analysis can be observed or identified. Speech recognition is a phenome recognition, also useful for recognizing the accent or to identify the speakers. Search engines, query matching and ranking the algorithms or auto completion features. In time series analysis, seasonal pattern identification and forecasting, and robotics, where the objects can be detected by tracking, gesture recognition, and autonomous driving, etc. In recommendation system, the content-based filtering and exploratory recommendation, and in music analysis, chord recognition, music recommendation, genre classification, etc. So likewise, social media analysis, where the sentimental analysis, trend analysis, and topic modeling. Quality control, signal processing, process monitoring, and medical diagnosis, image analysis, radiology, pathology. And in security, intrusion detection, malware detection, and fraud detection, fingerprint identification. Financial analysis, where the stock market can be analyzed, credit risks can be analyzed, and also in IoT, Internet of Things, where the predictive maintenance can be handled with energy management. So one of the example where the pattern matching is possible, take an example of searching for a specific word in the book. You can use pattern matching to find all instances of that word present in the book. So if you look at that, applications of pattern matching include identification of phrases within the larger text, finding specific shapes within an image, distinguish sound patterns in the spoken language, search all instances of particular gene within the larger set of DNA sequences. Example, it is given in the text. You would have seen that A, B, C, D series of characters, and the pattern need to be identified as AABA, and that is present in two places. So the pattern found in the index 0 and in the index 9 and in the index 12. So another example of pattern is to find the regular expression. So in the regular expression, the rational expression is a sequence of characters that define the search pattern that is used to match patterns of characters within the large piece of text. For example, if you want to search Voila in a piece of text, you can use the regular expression Voila to define the search problem pattern. Regular expressions can also be used to match the patterns of characters based on some specific rules or constraints. For example, characters that occur within the parentheses or the characters that are followed by a punctuation mark. So regular expressions are used in many programming languages and text editors as they allow for sophisticated searches and manipulations of text data. Common applications include text processing, programming, data mining, data validation, and natural language processing. So the pattern matching algorithms are in different names. Naive string matching algorithms, which is comparing character by character, but it is slow and inefficient for large data sets. The other one is Nath Morris Pratt algorithm, which is a very popular one, and it is comparing the structure of the search pattern. It is faster for largest data sets. And by Moore algorithm, which is used to scan the pattern from right to left using pre-computed tables to determine the next possible match location. And regular expression matching algorithms are designed specifically for matching patterns defined by regular expressions. And Aho Korasik algorithm, which is used to search multiple patterns in a single pass. And Rabin-Karp algorithm, which is used to compute a hash value for the search pattern and then compares this hash value to the hash values of all possible patterns in the text. And Smith-Waterman algorithm, which is scoring all possible alignments between two sequences and then identifies the highest scoring alignment. 11th, then the last one is 11th train distance algorithm, which is used to compute the edit distance between two sequences where each edit is deletion, insertion, and substitution of a single character. It is generally used in spell checking and autocorrection features. So on a conclusion note, pattern matching is a core component of problem solving in many areas, and it is helping decipher patterns in data to detect anomalies, identify relationships, and create models for predictions. With the increasing importance of data-driven decision making, pattern matching has become an essential tool for aiding many critical decisions in business, science, and technology. Using pattern matching in machine learning, we can develop predictive models that can be used in image recognition, image analysis, natural language processing, fraud detection, and predictive maintenance, etc. Thank you, students. Let us see you next class. Thank you.